Okay. Hello everyone. Good evening. I hope all of you are doing well. In yesterday class, we discussed about the molarity, right? The concentration term topic we were continuing from the last to last lecture. So today also we will cover some of this part, that is normality, and then we will start our topic equivalent weight. In normality, we have to use the topic equivalent weight. After finishing normality, we will continue further the further details of this topic equivalent weight, right? Let us start then. Yesterday in molarity, we covered some of the topics like relation with the weight by weight, weight by volume percentage, then relation with molality, then molarity change on dilution, and you can say mixing of 2 or 3 solutions. Fine. So we'll continue this part, and now the next topic is normality, right? After that we will cover equivalent weight in detail, right? Okay. The next term is normality. How we show it? By capital N. We will show it by capital N, right? So first of all, what is normality? If I write the formula, normality is number of gram equivalents of solute instead of number of moles. In this case, you will have a number of gram equivalents of solute divided by, you can say, volume of solution. This is volume of solution in liters. In topic molarity, upside in numerator, what was there? Number of moles of solute. So what is difference here? The difference is coming here. It is number of gram equivalents, not number of moles. So this is new for us. This is new thing for us, and we'll understand what it is. Okay. Let's move step by step. Up to now, you have seen the molar weight, right? You have seen the molar weight. You know molar weight, right? Molar weight is the you can say weight or mass of 1 mole of a compound. Similarly, like molar weight, normally I was showing by M, I was showing, right? Similarly, there is one more term. We will use equivalent weight. This will be our next topic in detail. So one more thing, you will see equivalent weight. Okay, I am showing this by M. I am showing this by E. E is the equivalent weight, right? E is your equivalent weight. So to find the gram equivalents, I have to find the equivalent weight. Okay. So for now, just try to understand how we can relate these two terms. I am telling you that equivalent weight, E, equivalent weight is actually the molar weight divided by the N factor of that solute or that substance, I can say. For now, I'm telling you in short. I'll come to all these points in detail. For now, in short, if you remember, equivalent weight is what? Molar weight by N factor. What is this N factor? We will do this topic in detail also, don't worry. So E is what? Equivalent weight is what? Molar weight by N factor. In our solution chapter, in our solution topic, if I talk about, then you will see solutes are of 3 types basically. In our solutions, I am saying, right? Which solute is there? Thank you, sir. So, in our solution, we will have 3 types of solutes basically. One will be acid, one can be base or a salt. So, if you know the N factor of these 3 things, you will be able to do the question of normality at least, right? And then more details we will see step by step. Fine. So, here you can see what is the, okay, I am moving forward. So what is the number of gram equivalents? I will come back to N factor later on. First of all, how we find number of gram equivalents, right? How we find number of gram equivalents? You will see given weight. How we can find it? Given weight divided by equivalent weight. It is given weight divided by equivalent weight, right? How we find number of moles? number of moles was given weight by molar weight, whereas number of gram equivalent is what? Given weight by equivalent weight, right? Okay, I'm writing this given weight by W, and what is it? Equivalent weight is E. Fine. Or I can say further, if you want to go, you want to relate number of moles here. So what is E, beta? We know what is E. E is molar weight by n factor, right? If you further write this thing, so what is coming here? W by m, n factor going where? N factor going upside. Clear? So we can see here, given weight by molar weight is what? Number of moles. So I can say number of gram equivalent is what? Number of moles into the n factor of that solute, right? This is all detailed things, but up to now, if you remember, this much is good for us. What is it? Given weight by equivalent weight is our number of gram equivalents. In number of moles, it was given weight by molar weight, but in case of number of gram equivalent, what is it? Given weight by equivalent weight. Okay, got the point? Right, everyone? Fine. So now, if you want to write the formula properly, I'm coming back to the formula. Normality. What is normality? Normality is number of gram equivalents, right? Number of gram equivalents means what? I can see from here, I can say given weight by equivalent weight divided by what? Volume. Or here, if I go further, W, it is what? E. But what is E? M by n factor divided by volume in liters. Clear, bacha? If you solve this thing further, so what's coming here? I can write it as W by M, volume here, and n factor I can write upside, right? So what is coming, beta? Normality. What is this? Number of moles divided by volume of solution is molarity. So I can write one more thing here. Normality is what? Molarity into n factor. So these 2-3 terms are very much important. It's a relation between the normality and molarity. By chance you forgot everything, but you know the molarity formula. So if you find the molarity and multiply it by the n factor of the substance or solute, you can find the normality. Are we clear about this? Yes, bacha? Yes, Niranjan? Yes, sir, good evening. Right? Got the point? I'm saying once again what it is here. Normality is molarity into n factor. N factor I will discuss about it. I'm taking the next topic is n factor. Okay? N factor for 3 things I will take, that is acid, base and salt. We'll talk about acid, base and salt. Fine, bacha? I hope we are clear up to here. Done? Okay. So the next thing I am talking about n factor, right? To find the equivalent weight, I need n factor. In solution topic, we need only 3 things. So I am discussing about acid, base and salt only. So for acid, beta, what is the n factor? N factor for acid is its basicity, right? The basicity of an acid is its n factor. What is basicity? How many H plus ions in an acid can give, right? Is its n factor. For example, if we talk about HCl, HCl can give 1 H plus ion, H2SO4 can give it how many H plus? Can give 2, so its n factor is 2. If I talk about H3PO4, it can give beta 3. It can give 3 H positive ions, so its n factor is 3. Okay, clear, fine. Good, bache. Its n factor how much? 3, right? Similarly, if you talk about acetic acid, for acetic acid, the n factor is how much? The n factor is how much, beta? 1. Because it gives 1 H plus ion. Be clear, the basicity is the number of H positive ions an acid can give. It is not the H it is having. In the formula, acetic acid have 4 hydrogens, but it can give only 1 H plus ion in aqueous solution. So its n factor is 1, okay, not 4. Okay, be careful about it. So similarly, very common example if I talk about here, especially here students make mistake, H3PO2. If someone asks you what is the end factor of H3PO2, can you tell me? And one more I am saying it is H3PO3. Two things are there, H3PO2, H3PO3. Please tell me what is their end factor. Yes, please try. H3PO2 is hypophosphorus acid and H3PO3 is phosphorus acid. H3PO4 was phosphoric acid, or you can say orthophosphoric acid, right? Tell me if you have seen the structure in your previous classes. Please tell me. Yes, beta. Tell me what is coming. Yes, the end factor of H3PO2 beta is 1 because it can give only one hydrogen. Be careful about it. H3PO3 can give two hydrogen. Even it is having 3 hydrogen, but it can give only 1. Even it is having 3 hydrogen, it can give only 2. It depends on the structure actually. These are oxy acids. It depends on the structure. I will show you a little bit. Okay, I am showing you. It completely depends on structures. Okay. So similarly, if I want to find the equivalent weight, imagine I want to find the equivalent weight of HCl. How I will find? The molar weight divided by 1. For example, if I want to find the equivalent weight of H3PO4, what is that? M by 3, right? Similarly, if I want to find for the acetic acid, what is that? M by 1. So if you know the n factor, you can find easily the equivalent weight, right? What is the equivalent weight? Molar weight divided by the n factor, right? Clear beta? I was saying about the structure. Look at this. H3PO2. Actually, H3PO2 have this structure. It have PH bond, and here what we have? OH. Here also if you see beta, it is having H here 1, here having 2 OH. And the next one if you see, if we have H3PO4, you see H3PO4 have 3 OH. It can release all 3 hydrogens. H3PO2 can give only 1 hydrogen. That's why its n factor is 1 only. Because this OH bond is only polar. pH bond is not that much polar to ionize. This will not ionize, right? So it is unionizable here. It will not ionize. Here it can give 2 hydrogens and here it can give all 3. That's why its n factor is 1, its n factor is 2, its n factor is 3. Very common question in the NEET exam. Okay, you should know about it. Clear? The next thing is bases. I can talk about the bases. Next beta is bases. Right? For a base, if we talk about the n factor, the n factor is what? Acidity. What is the acidity of the given base? Right? The acidity. Example we can see. Imagine I am having KOH. KOH can give how many hydroxide ions? KOH can give 1 hydroxide ion. So you can see its n factor is how much? Its n factor is 1. Similarly, if you talk about BaOH twice or CaOH twice, it can give 2 hydroxide ions. That's why its n factor is what? 2 beta here, right? Similarly, if I take here something else, if I am taking here AlOH thrice, right? So it can give 3 hydroxide ions. That's why its n factor is 3. So a base is giving how many hydroxide ions? It will give its n factor, right? What do we call? We call it acidity of the base. Okay, this is the n factor. So definitely, if you want to find the equivalent weight of KOH, you will say its molar mass by 1. Similarly, if you want to find the equivalent weight of what? BaOH twice, what you will say? Molar mass by 2. Right? So in this way, using the n factor, you can easily find the equivalent weight. Okay, right? The next thing, if you see, the next thing is salt. These three things will come in our questions basically. Remaining part we will see as a separate topic, salt. So what is the N factor for a salt, right? N factor for a salt is total charge. N factor for a salt is total charge of cation, total charge of a cation or anion. Okay, be careful, it is or. You have to count what is the total charge on cations or anions, you can say, right? Total charge of cations or you can say anions, right? Whatever cation is there in the molecule, you have to take the total charge, right? Clear, bacha? What we will see here, we will see, bacha, what we are doing. Imagine, I am talking about the NaCl. I am talking about the NaCl, beta. NaCl is a salt. So for this NaCl, how we will find the N factor? How we will find the N factor, beta? For NaCl, how we will find the N factor, right? For NaCl, if you see, what is total charge of cation? We will see here the Na plus. We have what here? Na plus, and here what? Cl minus. It's Na plus and here we have Cl minus. So what is the N factor? 1. Plus 1 charge on cation and minus 1 charge on anion. Plus 1 charge on cation and minus 1 charge on anion, right? Similarly, so you can take plus 1 or minus 1, any charge of cation, or you can take charge of anion. Any of these is okay, right? Clear, beta? Now if we talk about CaCl2, if I talk about the CaCl2, what is it, beta? In CaCl2, if you see carefully, it's calcium plus 2, and what do we have here? 2 of Cl minus. It's calcium plus 2 and 2 of Cl minus. So what is total charge here? On cation I have total charge plus 2, and here total charge how much? Minus 2. See, its N factor is what? Its N factor is how much? 2. Clear? And the next thing I will say here, I will take one more example. Let us see what we can take, bacha. Clear? So please write up to here. So the N factor of salt is what? Total charge of cation or anion. Don't think, sir, here only Cl minus. No, Cl minus 2, na? Total minus 2. Here charge is plus 2, here charge is minus 2. So you can say 2 is the N factor. Here charge is plus 1, here charge is minus 1. So what is the N factor? 1. The total charge you have to take. I will take one or two more example, then it will be more clear. Fine? Clear, bacha? Let us see the next one. So please be clear about up to here, right, bacha? Are we clear about here? The next I am taking. Okay. The next one is, let us take this one. Example I am saying, imagine we are having Al2SO4 thrice. Yes, everyone, please answer this question. Try to find its N factor. I am having Al2SO4 thrice. Please tell me the N factor of this. Al2SO4 thrice. Tell me. Total charge of cation you have to count and total charge of anion. What is coming here? I am giving a hint. Al plus 3. 2 of Al plus 3 ions are there. And I am having 3 of sulfate ions, right? 3 of sulfate ions, right? Tell me, what is total charge? Plus 3 plus 6, and here what is charge? Minus 6. The total charge is plus 6 and minus 6, right? Total charge of cation is plus 6 and total charge of anion is how much? Minus 6. Fine, bacha? So what is the N factor of this? 6. N factor is 6. Here the N factor is 6. Clear? Yes, everyone? Mandeep saying 5. 6, beta, see carefully. 6. 2 aluminum ions, right? Plus 3, how many? Plus 6. Minus 2, minus 2, minus 2. How much? Minus 6. So any of these you can take. So what is coming? 6. Fine. The next you can talk about here. I am giving one more example. Carefully give me the answer. It is, imagine, I am saying here CaSO4. Tell me its N factor. And here I am saying, imagine Na3PO4. all of these are salts. All of these are salt. So please tell me the N factor. Yes, beta, yes. Okay, beta, okay, fine, beta, fine, don't worry. Right. Just to give you a hint, if you break it in two parts, if you break this in two parts, what's coming? It's coming calcium plus 2. And what's coming here? Sulfate, SO4 2 negative, right? So what is charge coming here? The total charge is coming plus 2 on cation, minus 2 on anion. What is N factor? 2. Easy? Yes, Monica, right? Kushi is saying 2, 2, 2, fine, very good. Similarly, if you look at the Na3PO4, look carefully. I am having 3 of sodium ions and I am having 1 of phosphate ion. So if you check carefully, total cation charge how much? Plus 3. And total anion charge how much? Minus 3. Total cation charge plus 3 and total anion charge how much? Minus 3. Right? So how much coming N factor? Yes. Its N factor is how much? 3. I hope we are clear now. How to find N factor of an acid and a base and a salt. That's what is important for us for now, for this topic I am talking about, right? More details we will see later on. Okay, bacha? So please do this question. A small question. Find equivalent weight. Question is find equivalent weight of. I am giving you 3 things. Give me the exact value. This time give me exact value. Acetic acid. First one I am saying. Next one I am saying CaOS twice. You have to give me exact value. CaOS twice. And the next I am saying imagine it's Al. Okay. You can take aluminum phosphate. Or you can take aluminum sulfate. It's your choice. You can take aluminum phosphate only. AlPO4 plus 3 minus 3. Aluminum phosphate you can say, right? Tell me, is it a fight? Tell me fast. You have to give me the values, beta. You have to give me value. Just for your help, I am telling you. For your help, I am telling you that calcium have a mass of how much? 40. And phosphorus you can take as 31 mass. Aluminium have mass 27. So find the molecular mass or molar mass divided by its N factor. Tell me the exact values. Find the molecular mass first of all and then divided by N factor, right? Then divided by its N factor, right? Clear? Move step by step. It is acetic acid. We know this. If you don't know the structure, I am telling you the structure for acetic acid. Actually, it can give you only one hydrogen. So, if you don't know its structure, this one, its N factor is 1. The molar mass you can find. The molar mass you can find. What is M beta? The molar mass. How many carbon? 2 carbon. 2 into 12 for carbons. 2 oxygen. 2 into how much? 16. And how many hydrogen? 4. So I think it is 60 coming, right? Now find the equivalent weight. Yes, 60 divided by its N factor, that is 1. So what's coming? 60 gram is the equivalent weight for the acetic acid, or you can say CH3COH. Fine? Good. The next one, if I say, the next one is, I'm talking about calcium hydroxide, COS twice. Calcium hydroxide can give how many? Can give how many beta? You can say OH. What is the N factor of this? What is its N factor? What is its N factor, beta? its n factor is how much? Its n factor is 2. It give 2 hydroxide ions. First find its molar mass. What is its molar mass, you say? Calcium how much? Calcium 40. 2 oxygen how much? 2 into 16, 32. And how many hydrogen? 2 of hydrogen. So what's coming from here? 40 plus 32, 72. And 2 beta how much? 74. Is it coming 74? Right? That's it. If you know the molar mass, what is the equivalent mass? It's a molar mass by 2. That is 37. Very good. That's it. Great, great. Yes, Prashant is giving right answer. Yamini also. It's very great. Fine. Nice. Now, the next one. Last one. Okay? Try this one. Aluminium phosphate. Third one, aluminium phosphate. You can say AlPO4. Okay? You check carefully. I'm showing a bracket because it can confuse you otherwise. Actually, it is aluminium plus 3. And phosphate means PO4, 3 minus. So first of all, its N factor how much? Its N factor is 3. Its N factor is 3. Its N factor is 3. Right? Clear? Now if you want to find the molar mass beta, what is the molar mass coming? What is the molar mass coming for this one? Aluminium how much? 27. Phosphorus how much? 31. Oxygen how much? 16 into how much? 4. What is the molar mass coming? Molar mass, tell me by adding this. What is the molar mass? Then we know very well. Equivalent weight is very easy. What? M by 3. What's coming molar mass? If you add this thing, 64 coming from here, 64 plus 31, 95, 95 plus 27, 95 plus 27, how much coming? Right? 122. 122 divided by how much? 3. Right? You are saying 46.5. You are saying 46 coming. Sure? What is the mass coming from here? Tell me what is mass coming? Aluminium 27, phosphorus 31, 60 into 4, right? 122 coming. Fine. Divided by 3. What is coming from here? 3, 4. 40.5 should come, I think. 40 point something. Check calculations properly. Check calculations, everyone. Give me again answer. Calculation are okay. Calculation are fine. Okay, Yamini is saying 40 point something. 40.5. Okay, okay, fine. Right. Okay, so whatever coming, almost 40.5 I'm saying, right? Calculations you can check by yourself once, okay? Then everyone, this is it, N factor about the, you can say your acid, base and salt. Your acid, base and salt. Fine? Now we will come back to the question of normality again. The question of normality. Now you are clear about the N factor, equivalent weight, so you can easily find the question of normality. Okay? Let us see. The next one. Imagine we have a solution here. We have this solution. This solution have 11.1 gram of CaCl2. This solution have 11.1 gram of CaCl2, and I'm saying here this is 1.5 liter, or I'm taking like, I'm saying it is 1500 ml solution. This is 1500 ml solution, right? The question is very clear. Find normality of CaCl2, or just I can say find normality of this solution. The solute is CaCl2. So find its equivalent weight, then find gram equivalents, and then go for normality. Do it fast. Yes, beta. Yes, yes, fast. What's coming? You see here, let us find the n factor first. I am moving very slowly here. Otherwise, so we can do directly, it's not lengthy thing. N factor is 2, right? If you want to find the equivalent weight, what is that? It's molar mass by n factor how much? 2. CaCl2 have n factor 2 because calcium plus 2, Cl also minus 2 here. M by 2, right? So what's coming? It's molar mass. If you find it, 40 plus 71 is coming 111. So 111 by 2. It is the equivalent weight of the CaCl2, right? We know the equivalent weight now. The next thing is normality. How we find normality? Given weight. Given weight by the equivalent weight divided by what? Volume of solution in liters, right? So this thing we have to do. Okay, bacha? So if you solve this thing, what's coming finally? Okay, Yamini is saying 0.13 is coming. Okay, let us check then. If I write it properly, 11.1 here, 111 into 2 will go upside. Here we have 1000 and here we have 1500, right? If you cut it down, what's coming here? 2 coming here, it's coming 3 here. If you cut down this thing, what is coming, beta? 10 coming? 10 is coming. Cut down here, what's coming? 5. So finally, what is coming here? Finally coming 2 by 15, I think. 2 by 15 normal. 2 by 15, or as you are saying, so let us check. What's coming? 0. 2 by 15, beta. So yes, almost 1 will come, 0.1 and 3 something will come. Fine, 0.13. Yes, Monica, Karthik, Yamini, all give right answer only, 0.13. Great, good. I am moving very slowly by showing step by step, okay? The next one, same type of question I am giving here. So here we have question and I am saying it is 800 ml of solution, and in this I am saying we are having imagine we are having 490 gram of sulfuric acid. It's 490 gram of sulfuric acid. So please find the normality of solution. Find the normality of solution, right? Find normality. Alright, bache. Yes, beta, Abhishek. Solve the question fast. It's 490 gram. You have to divide by. Tell me fast. It is sulfuric acid. Fine. For sulfuric acid, we know very well. Its n factor is 2, right? Its n factor is 2. So we know its equivalent weight how much? 98 is the molar mass divided by its n factor 2. So 49 gram is the equivalent weight, right? Okay. So what's coming from here? The number of gram equivalents we can find easily. What is normality? Normality coming how much? 490 is the given weight divided by the equivalent weight, 49, right? And divided by the volume. And to make it liter, I am taking what? 1000. Very good. So what's coming from here? 10. Here we have 800. So I can say it is coming 4. And what's coming here? 5. 12.5. Yes, bache. Yamini, Abhishek, right? Right answer. The 12.5 normal coming. 12.5. Great. Yes, Karthik also gave right answer, 12.5. Good. Okay, the next one. Find number of gram equivalents Find number of gram equivalents beta of calcium hydroxide. Find number of gram equivalents of calcium hydroxide in 600 ml. Be careful, in 600 ml of 0.12 normal calcium hydroxide solution. See carefully, they gave the normality, they gave the volume. They're asking you what? Number of gram equivalents of solute or calcium hydroxide. Right? Nothing is required here. You know the formula. Normality is equals to number of gram equivalents divided by volume. Just we have to multiply. Nothing else. Very simple. Fast. Notice these classes will not continue complete year. I think for 1 month it will continue. Up to the time you will join your offline classes. Okay, next one. So number of gram equivalent we are finding here, right? Volume is given and normality is given. So very simple question. Yes, 0.06 coming. Okay, that is fine. So the formula of normality is very clear. The value I gave 0.12. What is the formula? Formula is number of gram equivalents divided by volume. Volume was how much? 600 ml. Make it liter. Right? 1000 coming here. Very easy to get the answer. The number of gram equivalents coming how much? 0.12 into 600 divided by 1000, right? So if you cut it down, what's coming here? Finally, 0.12 is here, and you can divide, so you can come 3 and 5, right? What is the final answer? Okay, Sharanya is saying 0.07. 0.07, right? Normal. Sorry, gram equivalents only, na? 0.07. Calculations you can check once. Right? Okay. So 0.07 is coming. Fine, beta. Good. 7 2 you can say further. Right? So write a note here. Remember, like in the topic of normality, when you are finding number of moles of solute, using molarity you can find number of moles of solute beta. How? It was molarity into volume. Similarly, in solution, if you want to find number of gram equivalents, you are trying to find number of gram equivalents of solute. So you will do same thing. You will take normality into volume. Okay? Molarity into volume give you the moles. Normality into volume give you what? Gram equivalents. Fine? Okay, bacha? Clear, bacha? So what is it? Molarity into volume, and here we have normality into volume. Fine, bacha? Be careful. Here it is gram equivalents, and here it is what? Moles. Fine, bacha? Be careful about it. Now, as we have seen already, we know the relation that, if you want to find the normality, you can use relation and factor into what? Molarity. Right? So I am giving you one question on this basis. Please answer me fast. Right? I am asking you the normality. By giving you, I am having here 0.12 molar. Imagine I am having here BaOS twice solution. So I am asking you the normality of this. Similarly, find normality of 0.2 molar Al2SO4 thrice. right? And similarly, I'm asking beta, you have to give normality, right? It is 0 point, I'm saying 1.5 imagine, and here we have molar, and here I'm saying we are having sulfuric acid solution, S2SO4 solution. Fine. Please give me the molarities. Okay, I get the molarity. You have to find what? Normality. You do it fast. Good, good. Yes, beta. Make it fast. Okay, great. The formula is very simple. You have to use the n factor into what? Molarity. You have to use the n factor into molarity, right? So this is 0.12. What is the BaOS twice n factor? Its n factor is how much? Its n factor is 2. Its n factor is 2. So I will do one thing, 2 into 0.12. So how much coming from here? This is coming how much? It's coming 0.24. It's 0.24, right? Good. Hey, bacha. Here we have it's 0.2 molar. So 0.2 into how much? Its n factor how much? Its n factor was 2. And its n factor how much? N factor is how much? 6. Just now we did, na? So 6 into 0.2. What's coming? 1.2 normal, right? It's coming 1.2 normal. Fine. The next one is sulfuric acid. Its n factor how much? N factor also 2 beta. So 0.15 into 2. I can say 2 into 0.15. What is coming here? So 0.3 coming, right? 0.3. Very good. I hope we are clear now. Fine, fine. Good. Great. Done, bache? Okay. So this is the way you can solve the question of your normality. If by chance you forget about the normality, just do one thing, find molarity first and then multiply by n factor. You can easily find. Right, beta? Okay. Done, bache? The next thing is, okay, we'll start beta. After this topic, we'll see the later part, right? The next thing is, let us start the next part. I'm giving you some of the questions from the PPT. Try to solve this question from the PPT, right? Now, whoever this Abhishek is, calm down. Just try to attend the class peacefully, right? Or you can do your time pass later on. Let us see some questions, right? From these previous year questions, right? Good questions. So please try to solve these. Now we have seen most of the topics, important points. Now try to solve these, right? Think about it. Make it fast. Yes, everyone. The two solutions of a substance that is non-electrolyte are mixed in the following manner. The first one is 480 ml and it is 1.5 molar per solution, and the next thing is 520 ml of 1.2 molar. What is the molarity of final solution? Remember that mixing, two solutions mixing. If both solutions are of same substance, you will apply what? M1V1 plus M2V2 equals to what? M3V3. So please give the right answer fast. I am giving a hint here. You are mixing solutions of same substance. What's coming? M1V1 plus M2V2 equals to what? M3V3. As we are just mixing two solutions, so definitely V3 is what? V1 plus V2. Give me answer. Right. Make it fast. Okay, 1.34. 1.34 is coming. Examining good beta. What's coming? The first one is, they are saying 1.5 mole, right? 1.5 molar into the volume is how much beta? 480 ml. plus you can say the next thing is it's 1.2 molar. The volume how much? The volume is 520 ml here, right? And the next thing is easy, the M3 we have to find. And what is V3? V1 plus V2, what is coming here? 1000. It's coming 1000. Good. Okay, great. Okay, that's it. So if you solve this thing, most of you are saying the answer is coming which one? Okay, great, but great. If you calculate this thing, this multiply here and this multiply here, what's coming? This is coming 1.344, right? Or you can use some common sense also here. Yesterday I told you one question, right? Yesterday I told you one question on this basis. Yes, everyone, one thing I told you yesterday, that imagine if one solution is having 1.5 molarity and the other one is having how much? 1.2 molarity, right? Right? It is 1.5, it is 1.2. So definitely the final solution will have molarity in between these two. It will not be more than this higher value and can't be less than this value, right? So what is coming? Can we use it? Yes. 2.70 more than 1.5? Not possible. 1.344 is in between both, right? The next one is 1.50. No, 1.20. So always if you are mixing two solutions, the middle one, the final solution will have molarity which will be in between both. Yesterday last question was same like this one, right? If you want to go for the exact value, the formula you know. Otherwise, if you want to get the answer only, it's very easy. Yes. Yes. Great. Good bache. Fine. The next one. Very easy again. 6.8 gram of H2O2 present in 100 ml of solution. What is the molarity of solution? Very easy again. Please make it fast. Give me answer. Yes, better fast. Make it fast. Make it fast. Yes, beta. We will do question from every book and everything in your offline classes. Calm down. Right? Okay. Try to solve this. What's coming here? Again, very easy. The formula of molarity is very clear. What's molarity? N by V, right, beta? So what's N by V? 6.8 gram is a given weight divided by how much? What is the molar mass of H2O2? 34, right? 34 is coming, good. And what is the volume, beta? Volume they are saying 100 ml. Make it liter. Make it a liter, right? So what's coming from here? I will write 6.8 divided by 34 and upside how much? 10. So yes, it is giving 2 answers, right? 2 is given. 2. Very easy again. Very easy again, right? Great. We have to move step by step. We have to be clear first of all about the basic topics, then we will move to the next one, right? Great. Everyone done? Okay, Monica, Karthik. Okay, fine. Done. The next one. Okay, is the next one. If the concentration of glucose in blood is 0.9 gram per liter, what will be the molarity of glucose in the blood? Right, beta? Make it fast. Solve it. The concentration of glucose is given in the blood. You have to find the molarity. Fast. Okay. Give me answer very fast. They are saying solution is what? Be careful about it. They are saying 0.9 gram per liter. Glucose is there, right? But you know what is molarity? Molarity is number of moles by volume, right? Molarity is number of moles by volume. It is not weight of solute by volume, right? What's coming? Right. Yes, 0.9 gram per liter. I will convert the gram into moles. How, beta? By dividing the molar mass. 0.9 divided by 180. What's volume coming? Volume already given what? 1 liter. So 0.9 divided by how much? 180. Fine? Done? Yes, very good. Very good. What's coming from here? 0.005. Great. So first of all, we have to be clear about the formulas. What are the formulas and the relationship? We have done many questions, right? Great, everyone. Right answer. Okay, done. Next one. Is it fast? Easy question again. Very easy. Wait fast. Just hold for 1 second. Remove this person. Yes, beta. Run up to here. Fine. What they are saying, bache, here? Look carefully. They are asking the molarity of solution and they are saying this much of urea is added. So very simple again. What is the molarity? Molarity is what? Weight of urea given 0.01 divided by the, we have to find the moles, na? What's mole? Divided by 60. The molar mass and divided by what? Remember, maybe a little new for you, it is decimeter cube. Decimeter cube means ml. So I can say here they are saying, decimeter cube means liter. So they are saying here what we have, it is 0.3 liter. So maybe some students can confuse here. It is 0.3 liter, right? So I will divide by 0.3. So mole of solute divided by volume. What's coming from here? Yes, beta. 0.01 divided by 60 into 0.3. Fine. What's coming? Yes, everyone. What's the final answer? Tell me. If you solve this, what's coming? Fast. Give me the final answer. Yes, beta. Make it fast. What's coming answer? Okay. This is giving. This is coming. They're asking you what? They're asking you molality. They're asking the molarity, right? Okay. Instead of molarity, they're asking you what? Molality. Okay, you can do this thing also. First coming. Be careful. Here we found what? Here we found the molarity. 0.01 divided by 60 are the moles divided by 0.3. It is they gave water here. They gave water. Then it's okay. 0.3 kg you can say. Fine. We are finding molality, not molarity. So it's okay. Instead of solution volume, they gave me what? Water volume. So be careful. If you want to find the weight, what is weight, beta? Weight is volume divided by density. If volume is 0.3 liter, right? Liter means how much? To make it, you can say ml, 1000 I will take. And what is density? Density is 1 gram per ml, right? So same thing will come here, right? First is coming, okay. Check calculations properly, you will get the answer. Fine. First one, great. I am saying once again, we are finding here molality, so I need weight of solvent. And by chance, they gave me volume of solvent only instead of giving volume of solution. So from the volume, we can find the weight. So weight will come how much? 0.3 kg. Right? So by chance we solve it correctly only, right? Even we are finding molarity. So by chance we got the same answer. Okay, bacha, right? Okay, next one. Density is given. They are asking the molality. Density of 2.05 molar solution of acetic acid given. They are asking the molality. Yesterday we did this. We write a relationship between the molarity and molarity. So please use it. Give me answer. Yesterday I gave the formula, right? What was the formula? Molality is 1000 into molarity divided by 1000 into density minus m here. What is it? Molarity into molar mass of solute. It's a molar mass of solute. Fine, bache. Make it fast. Make it fast. What's coming? 1000 into molarity. They gave 2.05, right? 2.05 divided by 1000 into here density, that is 1.02. Good. Minus of molarity, that is 2.05 into what's coming? Molar mass of solute, acetic acid. Just now we have seen the acetic acid is CaStCOH. So from here you can say the molar mass how much? 60 gram per mole. You can take here 60 gram per mole, right? So I will multiply here 60. Can you solve this thing? Give me answer. What's coming from here? Can you solve this thing? Give me answer. It's coming 2050, right? How much coming here? 1020 minus how much? 16 to this one. What's coming? 1 to something? It stays 123 something. Okay, so whatever coming from here you can solve it easily. We are having here 60 into 2.05. So 6 into 5 will come how much? 30. 6 to 12. Okay, 123. So you can solve this thing. It's coming 2050 and divide by, if you are removing this thing, so 23 will go, and I will say 8 something, 897, right? 897. So 2 point something should come. So 2 point something will come. 2.28, right? Good. Right, Monica, Karthik, right? Fine. Okay. Namaste. I hope we are clear up to here. Fine. The next one is, yes, Peter. If the concentration of glucose in blood is given, okay, this is the same question I think we did just now. I think this come again. Okay, very simple question again on basis of dilution. So please give me answer. Very simple question on basis of dilution. Okay. Okay, great. Yes, sir, what's coming here? Tell me. Yesterday we did these type of questions. So 500 ml is given in 5 molar, diluted to how much beta? 1500 ml, right? We know very easy question. It's M1 V1 equals to what? M2 V2. M1 is how much? M1 is 5. Volume is how much? 500 ml. M2 beta. M2 we have to find. And volume they gave how much? 1500 ml, right? Diluted to 1500 ml. Be careful. They are not saying diluted by 1500 ml. Diluted by, so that means they will add extra water 1500 ml. But here they are saying we are diluting it to 1500 ml. So they gave me V2 directly, right? So what's coming? It's definitely, you can say beta, you cut it down from directly here. So I can say 5 by 3. Very easy to find. How much? 1.66 molar. It's 1.66 molar. Good, good. Great. All of you are doing good, beta. All of you are doing great. Very good. I'm taking the next one. Okay, now this one. Concentration of solution means they're asking the molarity. Be careful. Concentration of solution means they're asking molarity. So look at the question. Very easy again. Very easy. Very basic question we are doing. Okay. Tell me what is the answer. They are saying here we are having so many molecules of urea. So you can find the moles from here. And they are giving the volume of solution. So please give me answer fast. So what is the molarity? What is the molarity coming? What is the molarity coming? Yes. How you can find the moles better? How you find the moles? 6.02, 10 to power 20 molecules. I can make it moles divided by Na. Number of molecules divided by Avogadro number to get the moles. Divided by volume of solution, how much? 100 ml. We'll make it what? 1000 here, right? So if you cut it down, if you see carefully, 1000 comes, huh? If you cut down this number, what is coming? If you check carefully, it's coming 1 by 1000 only. Already here, what is it? 100 is there. And upside, what do we have? 1000, right? Cut it down. So what's coming here? 0.01 molar. How much coming? 0.01. Yes, Chaitanya, Monica. Right. 0.01. Great. 0.01. A. Yes, beta. Done? Great. Fine. Okay. Next one. Okay, tell me. Again, very easy question. Look at the question, what they are saying. They are saying 1 mole of any substance contains this much of atoms or molecules. It is definition of mole only. The next thing is number of molecules of sulfuric acid present in 100 ml of 0.02 molar sulfuric acid solution. They gave me molarity. And they're asking number of molecules of solute, they're asking, right? Very easy again. What is molarity? Molarity is number of moles by volume. So first find number of moles. From number of moles, we can find molecules. How? Very easy. Just reverse question of the previous one. How you find? Number of moles into Avogadro number and into Na. What is the molarity given? Molarity given 0.02, right? You're saying I have to find number of moles. What is the volume? Volume they gave 100 ml. 100 ml. Let us make it liter first of all. If you cancel out this part. So how many moles are coming? You can say 0.02 divided by 10. So if you write properly, it is 2 coming, 2 10 to the power minus 3. This much of moles are present, right? But they are asking molecules, right? So what's the molecule beta? I am saying number of molecules. Because in the question they are asking molecules, not moles. So what is N? 10 to the power minus 3 Avogadro number, right? 10 to the power 23, right? You can see from here, this will give you 12 almost, 12, 10 to the power 20. Okay, fine. Which one is coming? Which one is coming? Okay, fine. A. Okay, first option, okay. Again, right answer only. All of you give that answer. Make it fast, everyone. A, okay. Okay, I hope you are clear about this. Next one. Okay, fine, beta. So we have seen, we have solved some of the questions. Just in few seconds, I am giving you one or two points which is remaining, and tomorrow we will start our topic equivalent weight once again in more detail. Today though we have seen the topic equivalent weight in terms of only acid, base and salt. Tomorrow we will see the details, more details about the equivalent weight. Okay, so one small thing I am giving, like we did dilution case or mixing case in case of molarity, same thing can be done in case of normality also, right? So if by chance dilution case come beta, so if dilution is going on, so you can apply same thing as molarity, N1 V1 equals to what? N2 V2. Exactly same, nothing different, right? The next thing is on mixing. On mixing, same type of solution. Like yesterday we did in case of molarity, same is applicable for normality. What's coming here? N1 V1 plus what? N2 V2 equals to N3 V3 equals to N3 V3, right? Okay. And one more very important thing, if by chance question is coming, imagine sometimes they give acid mixing, very special case, when they give acid mixing, two strong acid if they mix beta, they are mixing solutions of two strong acids. I will take 1-2 question in tomorrow class from this. So I will apply this one. I have to find the final concentration of H plus ion, so I will apply N1 V1 plus N2 V2 here divided by V1 plus V2. Be careful, whenever you mix two acids and they ask the final concentration of H plus, you will apply this one. I will take some questions tomorrow, okay, from this one. Similarly, if you mix base solutions, if you mix beta, if we are mixing two base solutions and you are asking, sir, finally what will be the OH negative concentration, then we will apply this one. We will say N1 V1 plus N2 V2 here and divide by what? V1 plus V2. Right? What is 1,2 here? It is acid 1 solution, acid 2 solution. What is 1,2 here? It is base solution 1 and it is base solution 2. Okay? Clear? I am taking one example here. You understand? Carefully try this question. Very easy. I am saying here, imagine I am having here 0.2 molar H2O4 solution, a strong acid solution, and I am saying volume is 300 ml. And with this I am mixing, imagine 0.1 molar HCl solution. And volume I am saying, imagine it is 200 ml, right? I am mixing two acid solutions. And they are asking finally, find concentration of H plus ion in final solution. If this question come by chance, So do not solve this question in terms of molarity because you can do mistake. If acid-acid mixing is there, then try to solve the questions using molarity. Sorry, using normality instead of molarity to avoid the mistake. Right, beta? Karthik is asking, Karthik beta, when they gave initial molarity, they ask you final molarity. Use what? M1 V1 equals to M2 V2. When they give initial normality and they're asking final normality, use N1 V1 N2 V2. Getting my point? If they're asking normality, use N1 V1 equals to N2 V2. If they're asking final molarity, use N1 V1 equals to M2 V2. But in case of question of acid-acid mixing, base-base mixing or acid-base mixing, use normality instead of molarity. I will take 1-2 question tomorrow also from this topic. Today time is less only, so I am trying to tell you this part, right? Don't try to solve this question in molarity, otherwise you will do mistake. First do one thing, get its normality. What is normality of this? Its normality is 0.4 normal, right? Because n factor 2. What is its normality? Its normality is how much? 0.1 normal. Clear, bache? Right? What to do? We have to find the H positive concentration finally. What will do, beta? N1 V1 0.4 into V1 300 plus 0.1 into what? 200 divided by 300 plus 200. What's coming from here? Yes, beta, tell me. 120 plus 20. What's coming? 140 divided by how much? 500, right? This is cut down. So what's coming? 7 divided by 25. Okay, so 0.28 is coming. Fine, beta. 0.28 normal, you can say, right? 0.28 normal. Got the point? Or you can say 0.28 molar also, because H positive have how much N factor? 1 only. Okay, so tomorrow I will take some more examples from this type of questions. Acid-acid mixing, base-base mixing and acid-base mixing. Okay, bacha? I hope we are clear up to here. See you tomorrow. Tomorrow we'll continue this type of questions and the topic equivalent weight. Okay, bacha? Bye then. See you tomorrow.